Okay, good morning, everyone. So today's our topic is topic 6. So according to the planner, yeah, today's topic is going to be on it's going to be on biostatistics, yeah, introduction to biostatistics. Introduction to Biostatistics. This today is our topic 6. So the learning outcome. If you look at the slide, the learning outcome is to understand the basic concept, terminology of biostatistics, type of variable, measurement and measurement scale. And we are going to distinguish between population and sample, understand the measure of central tendency, and understand how data can be appropriately organized and displayed. So of course I cannot be covering all this in within 1 hour. So I will just cover what I can. The rest of it I will upload in the Google Classroom. Yeah. So let's look at the definition of biostatistics. Just a minute. Yeah. Definition. When statistic is applied in biology, yeah, including human biology, medicine, and public health. So if we call it as biology, and merge together with statistics, so it become biostatistics. So what do normally we get data from biostatistic? So normally the data will be number of patient attending a hospital, number of roads, accident, etc. So who introduced this term of biostatistic is Francis Galton. So his life you can see 1822 until 1911. Yeah, so he's called as the father of biostatistic. Right, under medical statistic. So under medical statistic, we deal with application of statistic method to study of disease. Yeah, how efficient is a vaccine. So we have a lot of things that we can study under medical statistic. Okay, health statistic. Under health statistic, we deal with application of statistic method to vary the information of public health importance. So we talk more about health, yeah, not so much about disease. All right, and then another part of statistic which is very important, we call it as vital statistic. We try to get data about government agency on data relating to vital events such as birth, death, marriage, divorce, yeah, which is reportable by local health authorities. So we call this also as a vital statistic, and it is also related to biostatistic. So what is the importance of biostatistic? It is important for research management, yeah, in certain specialized area. So people who are very active in research, they will find that the basic statistic is very useful in conducting clinical study and field surveys. It is also effective presentation of their finding in reports, writing in journals, and in professional meeting. So by doing all this research, you are actually contributing, yeah, contributing by publication in the journals. All right. A collection of recording of observation. We have studied previously. We have a few methods of collecting data, and one of the method is observation. Yeah, observation is a uh, is a what is that? Is a type of data. Yeah, when you collect data through observation, yeah. So the data that you get, we call it as data. Yeah, data. So it's a recorded observation. Okay. So definition here, so statistics is a science and art which deals with So when you say statistic, you don't only collect data, you do classification, we do tabulation, we do presentation and analysis, and then we make a conclusion. Same like your report writing, yeah. You need to collect the data and then you classify according to the collection, and then you display your data through presentation and analyze, and finally you make a conclusion of your study. So statistic, yeah, you can get a weight of 1% or you can get a weight of 100%. All right, so now we have type of data. This also I already covered last lesson about type of data. We have primary data and secondary data. Okay, and you will come across the term descriptive statistic and inferential statistic. Okay, what is the important between the two terms here? All right. When you do research, when you collect a data, you are only dealing with sample. Yeah, you're dealing with sample. So sample is the representative of a population. Of course, you cannot do a study about the whole population. So you just pick a group, and that group must represent your study. For example, if you're doing a research about um, HIV patients. Okay, if HIV patient, of course your sample have to be consist of HIV patient. Or you're talking about passive smokers. Passive smokers, of course your sample, yeah, must have passive smokers. All right, passive smokers. All right. So from the sample that you collect, yeah, you can summarize or describe the important characteristic of a known set of the population data. So from your sample, you can explain about the population. So it must be really represent your population. So for example, if you're doing your research only with PIDC patients, it does not represent the whole community, yeah, the whole community, because we have few states. Yeah, we have few states. And also we have few clinics who are dealing with dental, public and private. Yeah. So whenever you just concentrate in one portion, then you cannot generalize. You cannot generalize your findings. Your finding is only localized in your population, the IDC population. All right. Okay. And then inferential statistic. So when your data represent the population, then you can do a generalization to the population. So you're finding, okay, let's say you want to find a solution, yeah, a solution for a illness, yeah, or you want to find out about the level of awareness among children, school going children. So when you're talking about school going children, we cannot just focus on Penang Island. So you need to get your population from all the states. Then you can do a generalization about the population of Malaysia, right? So that is inferential statistic. So when you from this, but most of the time our research only stops at descriptive statistic. We don't go into inferential statistic in PIDC. Yeah, because of the reason that I explained just now. All right. So when you collect data, we have talked about this before. Method of collecting primary data: direct personal observation, indirect oral investigation by interview, investigation through schedules. Yeah. So it is a data collected by a particular person or organization for her own use. So we call it as primary. If it's a secondary, the data has been collected. Yeah, has been collected. So publish official report, journal and newspaper, yeah, local government publication, university and research institute publication. Okay. So what is the difference between primary and secondary data? You can read this on your own. Yeah, I have discussed this before generally. Yeah. And primary data are normally raw material. Secondary data is a form of finished product. They have passed through the statistical method. Yeah, that means the data has been analyzed. Maybe has been analyzed using one kind of method. Now you're collecting the same secondary data and you're analyzing it using a different statistic method. Yeah. Okay, primary data are according to the object of investigation and are used without correction. Yeah, but secondary data are corrected for some other purpose and are corrected before using it. Collection of primary data required large sum of energy and time. Secondary data are easily available from secondary sources. Yeah, it could be published or unpublished. All right, variable. A variable is an attribute that describes a person or place or thing. Okay, what is variable? Variable is what you are finding a relationship. Okay, for example, hours of studying and the performance. So hours of studying is a variable. All right, or we say um, the boys perform better in mathematics compared to girls. So your variable is gender here, right? So it's a variable that attribute that describe a person, a place, or a thing. So we have qualitative and quantitative variable. Some of the research we can't be using qualitative method because it depends on the variable. I have mentioned before when your question is what, where, why, it is more appropriate to use a qualitative research, yeah, than quantitative research. Last lesson, you look back at the slides, I also have talked about qualitative type of data and quantitative type of data, right? All right, qualitative variable. So variable that yield observation on which individual can be categorized according to some characteristic or quality are referred to as a qualitative variable. Yeah? So qualitative variable, for example, uh, they take value that are names or label. For example, sex, yeah, occupation, whether you're employed or unemployed, marital status, married or single, education level, high, medium, or low. So all these are example of qualitative variable. Yeah, quantitative variable, they are yield observation that can be measured or considered to be quantitative variable. Normally quantitative, they are numbers like age, income, height, body temperature. Yeah? And then quantitative data, they have two types, discrete data and continuous data. Okay, what is discrete? Okay, very simple. Discrete means you don't have any in between number, like children, 5 children, 6 children, 3 children. You don't have 3.5. Huh? They are considered as discrete data. They must be always in a whole number. Yeah, whole number. Continuous data. Continuous data in which the measurement can be made in a precise value. For example, temperature. Temperature, it can be 13.3. Yeah, 26.5. All right, height also the same. You can have decimal or weight 57.3 kilo. So they are considered as continuous data. That means in between they still have values. Yeah. So now we look at the table below, which illustrates the quantitative variable and qualitative variable. So for example, height, it is a quantitative variable. Weight, blood sugar, how many percent per milligram, blood pressure, hemoglobin percentage, mg, qualitative, how short, how medium, how tall, yeah, underweight, overweight, normal weight, diabetic, non-diabetic, normal blood pressure, hypertension, anemic and non-anemic. So these are example of variables which can be quantitative or can be qualitative. All right. Normally, when we do a research, we have variables, and statistical data often classify according to the number of variables being studied. Depends when you are doing a simple survey like in this level for undergraduate. Normally we don't use too many variables, yeah? Because when you have too many variables, when you do the analysis of data, it become very complicated, very complex, yeah. And what are you doing here is just as a precondition for you to get your degree. So that's why we try to make our variable as simple as possible. So when you go back to your objective, yeah, research question, from the research question, you can see that the variables that you use, normally we stick to one variable only, yeah. So univariate data. When we conduct a study that looks at only one variable, then we say univariate data. Okay, for example, we conduct a survey to estimate the average weight of MBBS students second year in a medical college. So we are only working on one variable, the weight. So you're only looking at the weight. So that means you call it as univariate data. Yeah. What is bivariate data? As you know, you can see bi means two lah. Yeah. When we conduct a study that examine between two relationship, all right, two relationship, that means we are working with bivariate data. So for example, we conduct a study to see if there are relationship between height and weight of the MBBS student. Yeah? Since we are working with two variable, height and weight, so we call this data as bivariate data. That's all. Okay, what is the application of biostatistics? Yeah. So in physiological and anatomy, we will be using um, define limits of normality in variable like pulse rate, BP. Yeah. Find the difference between mean height of this example, Gujarat boys is always less than mean height of boys in Punjab. So we are looking at two different class of people, all right? Or find a correlation between height and weight, whether weight increase or decrease proportional to the height. So you're finding a relationship. Number of hours spent for studying will increase the performance in your final exam. So you're finding a relationship between number of hours and the performance, right? So in pharmacology, you will find the compare two drugs. For example, painkiller, which is a better painkiller? Is Panadol a better painkiller or any other painkiller? Yeah, which one? So you're comparing two drugs. So that is one of application in biostatistic in pharmacology. In medicine, yes, like you compare the two treatment. In dental, maybe you have few ways of doing a treatment, yeah, for decade tooth, for example. So you're comparing two treatment. In community medicine or public health, test usefulness of vaccine, attack rates. Yeah, so now like vaccine, we talk a lot about vaccine, Pfizer. So which vaccine is better, right? Sinovac or AZ. So you want to see the comparison. Yeah, role of causation factor in a disease. So you can get a general picture where we are using statistics in our health medicine, yeah, public health, community medicine, right. Besides that, also we can look at the leading cause of death, important causes of sickness, rise and fall of particular disease. We will get one kind of disease at certain period of the year. Maybe for, like example, dengue, when it's a rainy season. After that, the pandemic all gone. Yeah? Uh, so we have a time frame. Time frame. Okay, age and sex composition of the population. Sometimes we can find this particular disease only attack certain age group, maybe the small children, or this certain disease only attack the female population, right? Okay, and then we also can do a research on level and standard of health reach. If you look at 21st century, how is the health wise? What is the standard of the health? How much has it improved compared to the 20th century? So where do you get your sources here of data? Your main sources of collection of medical statistics are experiment, survey, or record. This is where your data comes from. So experiments are performed in various departments like psychology, biochemistry, etc. The results are employed in the preparation of dissertation. This one is higher level, but under your level, you might be doing presentation and you might be doing publication. Yeah. So how do you get your data? Maybe you get through the survey. The survey are carried out by health workers in the field to know the magnitude of the problem for the implementation of the control measures. Now, as we can see, our pandemic, yeah, COVID. So a lot of surveys are going not only uh, in the field of medical, but also in psychology effect, education, how much this pandemic has affected the life quality of life, yeah, of Malaysian, for example, or the total population in the world. Yeah, surveys are carried on, yeah, in many ways. Or you can also get from records, yeah, like records on a long period of statistic like birth, death, marriage, and all that. So now we look at the measure of central tendency. Tendency. All right. Um, Central tendency. So once you already collected your data, yeah, you want to measure. You want to measure the average. The average or the typical value of a set of scores. So when you get your scores, you want to find their central tendency. So what are we looking for in the central tendency? Mode. You have studied before in mathematics, mode means the number appeared many times. If the number appear many times, same number, then it is the mode. Medium is the middle number, mean is the average. So central tendency, we got three common measures: mode, medium, and mean. Okay, bimodal distribution. So when you have two modes, then it's called as bimodal. Like this, you can see the top score here. Yeah, you have two peak. So when you have two peak, yeah, when you have two peak, then it is called as bimodal. You have two modes. Okay. Multimodal distribution, that means you have more than two. Like in this picture, you can see five. Frequency five. Yeah, five times appear. What number appears five times? 79. 79. Yeah. So the same number is appearing 79 five times. And then this one is 80 something appears again. You can see three peaks, right? So this one is called as multimodal. You have three modes. When to use mode? The mode is not very useful measure of central tendency because it's insensitive to large change. Two data set are very different from each other, can have the same mode. By using SPSS, all this becomes very easy. Yeah. What I'm telling you is the theory behind, yeah, how to calculate manually all these values. But if you are using a software program, yeah, software program, you don't have to worry about all this mode, yeah, central tendency. You just click in all the data and then you just run through, you will get your answers there. Yeah, but you must know what mode stands for. Yeah. Okay. The mode is a primary use in numerical scale data, nominal scale. It's only measure of central tendency that is appropriate for nominal scale data, for nominal values. Medium. Medium is simply another name for 50th percentile. Yeah, that means it's a middle number. Yeah, middle number. The medium is simply another number for 50th percentile. That means you're finding the middle number. So you have 12 numbers. Yeah, you add up the 12 numbers, you divide by 12. If we have 30 samples, so you add up all, let's say you want to find the average age. The average age of your patient who comes to visit PIDC clinic. So you take all the 30 patient age, then you divide by the number of patient. Then it will give you the, middle number. Medium is a middle number. So you arrange them accordingly, 30. So the 15th number will be your middle number. So that is what you call as median. It is a score in the middle. Half of the scores are larger than the medium and half of the scores are smaller than the medium. So it's a middle number, right? You arrange. You arrange according to the ascending order. According to ascending order, and you take the middle number. So it become medium. Mode. Mode frequently appears. Many times the same number is coming out, so you call it as mode. So how to calculate the medium? Huh? It's best to let the computer to do it. Sort the data highest to the lowest. Find the score in the middle. So we have formulas for that. This is all statistic lah. But in our research, we don't focus so much on calculating manually. Yeah, it's outdated. Yeah. So for medium example, we have all the scores. We have to arrange the scores accordingly, and then we find the middle number. Find the middle number. So middle score is the middle number. The middle number is number 9. See middle here, 2, here also 2, here 3, here 3. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you take the middle number, the 5th number, right? So you plus both of it, divide by 2. Okay, so median, you have all these scores, sort out the scores. So you determine the middle number. Okay, so here you can look at this on your own when to use the medium. All right. You will come across the term squid, positive or negatively squid. That means when you get your score, the shape of the bell curve is either more towards right or more towards left. Okay, when do you get this? If you are doing a questionnaire with a Likert scale 1 until 5. So most of your respondent gave the answer between 4 to 5, 4 and 5, 4 and 5. Nobody give answer for number 1. All gave highly satisfied, highly agree. Malaysians are like that. Normally they like to give a higher ranking. Higher ranking. So now all your values are more towards the positively skewed. This one I can show you when you have a data. So it's just a theory. So when I teach you how to key in data with SPSS, then you will see the meaning, what is skewed. So it can be negatively skewed or positively skewed. Okay, mean. Mean is what? Average lah. Yeah, we have a formula for mean. Yeah, we have mean for population is we use the symbol mu. Mu. Can you see the alphabet like U? That is called as mean. Yeah, mean for population we call it as mu. Mean for the sample we use X. X with a line on top. Yeah. Okay. So now we are talking about population and sample. Sample also will have their mean. Population also will have their mean. So population mean, we call it as mu. Yeah. Sample mean, we represent it with x. Yeah. So calculating, how to calculate, I'm sure all of you know, you have to add up everything and then you divide with the number, how many scores. The sample here is 5, so you divide by 5. So the mean is 3. When to use the mean? You should use the mean when the data are interval or ratio scale. You check back and see what are data, interval data, ratio data. All this I think I have discussed before. And the data are not skewed. That means you get a bell shape where the middle value is just like a bell shape. Yeah. So the data is not skewed. The mean is preferred because it's sensitive to every score. So when the number changes a bit, your mean will change accordingly. Yeah. So if you change one score in the data, the mean will change. So it's very sensitive. So what is the relationship, yeah, between the central tendency? Central tendency, we're talking about mode, medium, and mean, these three. So when the distribution is symmetrical, the medium and the mean are equal. So when medium and mean are equal, you get a symmetrical distribution, which is very difficult to get in a survey. For normal distribution, yeah, normal distribution means your sample is normally distributed. This one you can check using SPSS also, whether your data is normally distributed or it's not normally distributed. From there, you will see whether to do a parametric test or non-parametric test. Yeah. So from here, I'm just giving you the basic only. From here, we will go to higher level. When you know it's not symmetrical, what kind of test can you do? Like you want to do t-test. Can I do t-test for everything? No. So what are the criteria for you to do a t-test? So when positively skewed, the mean is greater than the medium. Your mean is more than your middle number. So then it will be positively skewed. Okay, like this example. If negatively skewed distribution, the mean is smaller than the medium, then it will be negatively skewed. This is how it's skewed. So your bell shape, when it's a symmetrical distribution, bell shape, it will be like this. It's a bell shape. You will have like a bell, like a mountain. Okay, this shape that is given is more towards left. So when it's more towards left, that means it's positively skewed. For the second one, yeah, the central tendency is more towards right. So it's negatively skewed. The mean is smaller, the medium is bigger. So in general terms, central tendency is a statistical measure that determines a single value that accurately describes the center of distribution and represent the entire distribution of the score. The goal of central tendency is to identify the single value that can represent the entire set of data. Like you have a age group, yeah, age group. You want to collect your data from the patient's age 20 to 30. 20 to 30. So when you collect 20 to 30, you want to know your average of the patient that comes to treatment. So how do you know? You from here you can get the central tendency. So a single value, so the average will represent the entire set of data. So if we get older people, let's say the age is more towards 60, 63, 64. So now your mean will move towards the bigger number. So your data here represent older people. So that is the importance of central tendency. By identifying the average score, central tendency allows the researcher to summarize or condense a large sets of data into a single value. So you have a lot of data, you try to make it more meaningful, so you try to get the average score. Just like I told you just now, your patients, they have a wide range of age. Yeah? So central tendency serves as a descriptive statistic. So when students say they want to do descriptive statistic, what are they doing? They are actually simplifying the data by looking at frequency, looking at percentage, looking at mean. All these are considered as descriptive statistic. In addition, it's possible to compare two or more sets of data by simply comparing the average score. For example, um, I have two groups of students. One group of students, they undergo face-to-face lecture. Another group of students undergo online classes. So now I want to see which group perform better. Yeah, which group better. So I look at their performance. So from the performance, I got the mean. Face to face got a higher score. Online student got a lower mean. So from there, I can compare the average. Yeah, the average. So it's possible to compare two sets of data by simply comparing the average score, central tendency, for one set versus the average score for another set. So here, as you can see, the first drawing here is a normal contribution distribution. This is what I call as bell curve. Yeah, bell curve. And this one is the skew, positively skewed. You see the shape is more towards bigger number. That means your mean is more than your medium. Huh? So the mean, the medium, and the mode. So here, um, it is important for central tendency to be determined by an objective. So whatever test that you do, your statistic that you do depends on your research question. Yeah, research question. No single procedure always produce a good or represent the value. So therefore, researcher have to develop, yeah, develop commonly used technique for measuring central tendency, that is mean, median, and mode. Okay, and this part is mostly on mathematical side lah. Yeah. So we can get all this value through software. How to get the mean, how to get the um, here they tell you the theory behind it. Yeah. As I told you just now, they are very sensitive. Mean is very sensitive. Yeah, a little bit change in the scores, it will change the value of the mean. Yeah, so that is what is explained here. When your mean is not working, that means although the mean is most commonly used to measure the central tendency, there are situations where the mean does not provide the good or does not represent the value. Yeah, and there are situations where you cannot compute a mean at all. That means you have values which are extreme values. Extreme values, you get very small number, you got very big number, so they are very extreme. So the mean here, it does not work. Yeah, it does not work. So mean does not always work as a measure of central tendency. So we need to look at other alternative procedure available. Same goes with medium. Yeah. So here are the example of how to get your medium, middle number, right? Okay, so I have explained all these. How to report. The Reporting central tendency. This one I will explain later when we do our SPSS. Yeah, how to do report. Yeah, of your mean, medium, and mode by using graph lah. We use graph method. Yeah, we have box plot. We have a few ways. Yeah, to show all this. Okay, this one is just a revision of what we have studied. Probability samples and non-probability samples. So non-probability sampling, we have convenient sampling, judgmental sampling, quota sampling, snowball sampling, which I have explained before. We also have simple uh, random sampling, cluster sampling, systematic sampling. Yeah. Why? What is the advantage of sampling? So it helps to collect important information quickly, and you can also estimate the characteristic of the total population in a shorter time. Sampling also cuts the cost, time, and money, yeah, because you're not studying the entire population. And it also makes it very accurate. And you also can check if you have a lot of data, you tend to make mistakes, yeah, when you key in the data. So when you have smaller data, it's easier to check, but it's not necessary all the time. Small samples, yeah, can give you a accurate results, yeah? But only thing, sampling, small sampling, it becomes easier, yeah. You can save time and cost. This advantage, whether the sample is reliable or not. Maybe the sample that you pick from the population does not represent the whole population. Huh? Then it might become a disadvantage of sampling. Okay. So I think that's about introduction to biostatistics. Okay. So I think that's all for today's lesson. I will be putting up some more PowerPoint in the Google Classroom. Okay. All right. So that's all for today. Thank you.